Okay, so here we have a question from the integrated algebra regions relating to products and quotients of scientific notation, essentially kind of drawing on our intuition of the laws of exponents. Now, here we do have a calculator on hand, but I'm going to start by breaking this down logically. Here we're multiplying the numerator, right? It's 4.1 times 10 to the second times 2.4 times 10 to the third. So I'm going to just look at this numerator for a moment. And I'm multiplying everything so I can rearrange, right? When you're multiplying, you can rearrange and regroup your terms. So I'm going to multiply these two numbers, 4.1 times 2.4. I'm going to figure that product out. And then I'm going to multiply these two numbers, the powers of 10. 10 squared times 10 to the third. I'm going to figure that out, and I'll have my numerator kind of condensed so that I can break this thing down. So what are we going to get? Well, 10 to the second times 10 to the third is just 10 to the fifth. And the basic idea is that if you have two numbers with the same base, the base is the number you're raising to the exponent. So here the base is 10 in both cases. If the base is the same and you're multiplying, you could just add the exponents. And the idea there is that if we have two 10s we're multiplying here and another 3 10s, altogether that would be 5 10s. So we're simply adding up the exponents here. Now 4.1 times 2.4, you might have a calculator on hand. Sorry, I don't have my graphing calculator installed yet on this computer. So we have 4.1 times 2.4, right, 9.84. So now we have our numerator condensed. And now we also want to do the same thing in, we want to simplify or condense, keeping in mind our denominator here, which is 1.5 times 10 to the 7th. So here what we're going to do is divide, right? We have 9.84 times 10 to the 5th divided by 1.5 times 10 to the 7th. So here the nice thing is that we can just break this up into two quotients. We can think of 9.84 over 1.5, figure that out, and then multiply that by 10 to the 5th over 10 to the 7th. Now, this, the basic logic here is that if you're dividing by 1.5, you can think of that as multiplying by 1 over 1.5, right? And what that means is that 9.84, right, divided by 1.5, you can think of that as 9.84 times 1 over 1.5. And in other words, you can think of the division of both pieces and your denominator as multiplication by the reciprocal, like flip it over. And once you do that, once you use or think of this in terms of multiplication, that gives you the freedom that we're using right here to regroup, right, and kind of reorder how we solve this, because multiplication is both commutative, which means you can change the order, and associative, which means you can regroup it. Division is not, right, unless you think of division in terms of multiplication. Once you do that, once you make that switch, you have this ability to regroup. And now we can just set this up, so it's 9.84 divided by 1.5, 6.56, and here it's almost the inverse in the sense of our law before. When we are multiplying with the same base, we add the exponents. So you can imagine that it might make sense when you divide to subtract exponents. The idea here is that if you have 10 to the 5th, right, it's 5 10s over 7 10s, oops, 2, 3, 4, 5, 6, sorry about this, 7. When you're dividing, you can group these up, and 2 of them will cancel out, right? 3 of them will cancel out, 4 of them, 5 of them, and you're left with 2 in the denominator here. So every pair cancels or subtracts. And we do get a negative number here, so it's times 10 to the negative second, and that makes sense because our result here, if I rewrite it nice over here, these all divide out to 1 over 10 times 10, which is 1 over 10 squared. And that is 10 to the negative second, right? Those do mean the same thing. So here we have our answer in scientific notation. All right, hope this helped.